Hello, today we are going to talk about linear equations. We are going to go through some two questions, that's question 2 and 3, which in some cases becomes challenging to students. You can try the other questions. Now, in question 2, I'm going to do this question in a very simple way. Now, we have a line that is line A and line B here. So the two lines here, we are being told the two lines are perpendicular. So A and B, these coordinates forms one line, and then we have another line 2 here. So if the two lines are perpendicular, then the following situation comes out. Now, we have the line 1 and we have line 2. So because we want the value of k, which is the y coordinate here, we need to associate the line A with the line 2 in form of their gradients. If two lines are perpendicular, then the gradient of the first line times the gradient of the second line gives you a result of -1. So which means their product is equals to -1. Now, what is the gradient of any of the lines? So we can easily get the gradient of the second line here. So given that we have, that is L2, we have 3y plus 2x is equals to 5, then we can easily say that 3y is equals to, we can take this -2 to the other side, that is subtract 2x from both sides, we get -2x plus 5. Then we can get y here. So the inverse of multiplication here is division. So we divide by 3, that is its inverse here. So then we remain with, for this, you can see that we have y is equals to -2/3x plus 5/3. So what we are interested here with is the gradient of the line. Given the standard linear equation y is equals to mx plus c, then we have to know that the m, the constant m, stands for the gradient of the line. This is the gradient of this line. Okay, so gradient here. So, and the c stands for the y-intercept. So we can say that y is equals to mx plus c. We have said this is the gradient and this is the y-intercept. So then how do we relate it then? So this is the y-intercept here. Now, given the line that we have up there, we have that it is y is equals to -2/3x plus c. So the gradient of this line is equals to -2/3. So the gradient is equals to -2/3. And given the situation of two perpendicular lines, their product is equals to -1. So in other words, that the gradient of the m1 times the gradient of the m2, we get -1, which means that the first gradient of this particular line is equals to multiply both sides by the reciprocal of -2/3, which is times -3/2, which gives you 3/2. So 3/2 is the gradient of the first line, because the two lines are perpendicular. Then we relate this gradient with the first line. So how else do we get the gradient given the two coordinates? We know that given the two coordinates, gradient is equals to is equals to change in y over change in x. So we're going to relate this gradient with this particular gradient, which is a perpendicular gradient. So what is the coordinate of the first one? We know that we have negative 2, 1 and 2, negative k. So it is 1, which is the y coordinate, minus negative k. That is y here. So we have 1 minus negative k over negative 2 minus 2. This is for the x, change in x, which means that we are going to get 1 plus k over negative 4. So this is the expression of the gradient of the first line. So relate this one to the perpendicular gradient that we had. So which means that we are going to get 1 plus k over negative 4 is equals to 3 over 2. So if you cross multiply this, then you will get that 1 plus k is equals to 3 over 2 multiplied by negative 4, which gives you that k is equals to, when you multiply this, you get this is negative 2, that is negative 6. And you find the inverse of negative 1 of positive 1, which means negative 1, so which means k is equals to 7. So the value of k in this case is equals to 7. Okay. So we're also going to look at the second question that we have. So this second question is an easy question, but the student also needs some few concepts here. So x minus, so in the second question they want the angle. We have x, so this is question 3. We have x minus, we have is equals to negative 3. So given such a question, and then they are asking, calculate the angle formed between the line and the x-axis. Now we have to change this one to conform to the standard linear equation. Y is equals to mx plus c. So which means we can take y to this other side by adding y on both sides and then adding 3 on both sides. So we can get x plus 3 is equals to y root 3. So we can now express it in terms of this. So which means that we are going to get divide both sides, everything by root 3. So we shall get y is equals to x 1 over root 3x then plus 3 over root 3. Now this one has a positive gradient, which means that the line is moving in this particular direction. So this is what now they are asking. This is the horizontal x-axis and this is the line. So they want this particular angle. Now remember that this angle here can be obtained by the following relationship, change in y over change in x. So this is opposite over adjacent, which means we are going to use the tan. So the tan angle here means that it means the gradient of that particular line with respect to the x-axis. Now we have the tan of theta, which we are searching, is equals to 1 over root 3. Okay, that is where that relationship comes in. So in this case then, a student can use special angles to find this angle. You can use special angles here. Remember this can be 60, this can be 60, this can be 30 degrees, 30 degrees. This is an equilateral triangle. So give both sides 2 units. So this will be 1 unit, 1 unit. We can get the height. So 4, 2 squared minus 1 squared is equals to root 3. So the height is root 3. So how do we get then this? So if you use 60, opposite of adjacent will be root 3 over 1. But if you use 30, 30 here will be opposite is 1, adjacent is root 3. So in other words, you can just say tan 30 is equals to 1 over root 3. You see, and that is the answer. Alternatively, the student can say tan inverse of 1 over root 3. From your calculator, this one will give you 30 degrees. And that is how you solve this particular problem. So in other words, the gradient of a line is the same as the tan angle of that particular line. Okay, and that is how this question is solved. We shall continue with other series of questions in the next video. Thank you.